Hi, I wanted to briefly go over Lab 13 today. So let me share my screen real quick. So here's Lab 13. Let me make this a little bit bigger. So this is kind of a culmination lab where we're going to look at GNS3 and set up some routing and some DHCP. So here's some information on some of the routing technology for the WANs and so forth. But first thing we want to do is build this circuit here. So let me go into my GNS3 here. This full screen. I'm not going to save that yet. All right, so what we're going to do is grab two 3600 routers. And then 4 VPCs. So we'll do VC1, VC2, VC3, VC4. All right, so, and then we need to grab a couple of switches as well. Let's go through our switches, and it's just going to be an Ethernet switch. All right, so kind of move the routers up here. Switches here. All right, and then we can cable the PCs to the switch. Any switch port, doesn't matter. Fire that up. And then we want to configure these routers to have two network cards. So if we come into slots, we just want one of these cards in each one of these routers. So right click, configure, R2, and just add the NM1FE-TX in each slot. All right, now we're going to cable in between the routers. We want to do the 1 zeros. And then to the switch, we'll do 0 0. All right, so let's check our diagram again. All right, so that looks good there. Now, this left side here represents 45 computers. The right side represents 750 computers. So let's talk about that real quick. So let me get my snipping tool, and I just want to take a screenshot of this so I can mark on it, annotate it. All right. So if we look at our networks here, so I'll go with the green one. We have 3 different networks, right? We have one network here. We have another network here. Mouse. And we have another network right here. Now, this side, we said is 45 PCs. This side is 750. All right. And then, of course, we have this network here that has a total of 2 nodes. Okay. So when we look at these, I have in the lab where I want you to analyze this. And when we set up the networks, each PC on the same side of the network must represent the second and the last usable IP address. The router's internal adapters must be set to the first available network in the subnet. The link between R1 and R2 is a point-to-point WAN link. And then I have these networks. So we have 3 networks here. 192.168.0.0 is the network ID. The subnet mask is 255.255.252. 10.0. Then we have another network that is 10.0.0.0 with the 111, right? 8 ones, 8 ones, 8 ones, 6 ones. And then another network, 172.16.0.0 with a /26 network. So you should be familiar with working with a dotted decimal, a binary, and a slash notation for your subnet mask. So what I want you to do is look at R1, right, which is the left side of this network, and there's 45 PCs. So out of these subnet masks or network IDs, let me get here, which one of these can support 45 computers, right? Can a 252.0? Well, yeah, because what is this in binary? That'd be 8 ones, 8 ones, and then that's going to be 6 ones, and then 2 zeros, and then 8 zeros. So remember, the number of zeros represents the number of hosts. So this would be a /16, and 6 would be a /22. So 32 minus 22 means there's 10 zeros. So with the 2 to the 10th equals 1024. Okay, the one that says /26, which is this last one, that means that there are 6 2s and 2 times 2 times 2 times 2 times 2 times 2 is 64. And then this other section here is we have 8, 8, 8, 6. So that's 24, and 6 is a /30. So that means we have 2 2s, which means this one can support 4 total IP addresses. Now remember, we have to subtract 2 from this because the first one will be the network ID, the last one will be the subnet mask or the broadcast ID. So then this one, subtract 2 and minus 2 is 2. All right. So which side, where do we need at least 1022? Well, that needs to go in this network. Where do we need at least 62? That goes over here. Where do we need just 2? That one goes right here. All right. So if we come into our table, we know that, excuse me, the subnet mask, and I'm going to write all the subnet masks in dotted decimal, for R1 is going to be this value here. So I'm going to put that one right there. Let me undo that. There we go. Okay, so that's the LAN. R2's LAN is going to be this subnet mask. So that's going to be 255.255.255, and then it's going to be 2 1s, which would be 128.192. Okay, and then the WAN, which again, the WAN link is here, that's going to be the WAN will be 10.0, or no, 255.255.255 dot, and we only need 2, so that means there's 6 ones and 1 0. So this is 8, 16, 24, and 6 would be 30. So that in binary, this would be 128, 192, 224, 240, 248, 252. So that would be 252. And then this one is going to have the same. Okay. And then it says the first IP needs to be for the router. So on this one, now again, we're in this network. So I'm just going to paste this here. Oop. So on our router, in between our two networks, we know this is this network here. And the first one goes here, the second one goes there. Because there's only 2 in this network. There's only 2 IPs, right? .1 and .2. So 10.0.0.1, 10.0.0.2. We only have 2, so those ones are easy to figure out. But this one, so let's go to R1. So R1, I have a total of 10,024. The first network will be, another color here, will be 192.168. And just to make sure I get my numbers, 0, 0, and the network ID is 0.0. Our first usable will be .1. My next network is going to start at 192.168. Now, if I do all 16 zeros, that will get me to, or 0.0 is 256, 1.0 would be 512, 2.0 would be 3 times 256, which is 792, and then 4 zeros would get me to 1024. So my last IP will be 3.255. So my last usable will be 3.254. All right. So if I come into my table here, R1 LAN, the router, I'm going to give the first one 0.1. And then the last usable, all right, and then all of these PC1 and PC2 are in the R1 LAN, so they get the same subnet mask. And then PC1 is my second usable, which would just be one more than that. 2. All right, and then if I look at my diagram, these PCs will use this interface as their default gateway. And then on this side, these PCs will use this interface as their default gateway. So let's come back over here. So my default gateway for PC1 is R1's LAN, and then PC2 is R2's LAN, or our PC2's is R1's LAN. So again, this node here is the default gateway for anything on this side. This node will be that side. All right. So with our topology here, we know that PC1 and PC2 will connect through this switch, connect to this router, and then to get to PC3 and PC4, of course, we have to configure the network still. And then I have the instructions here. Once you figure out this table, and let me look at this table in today's lab. Let me look at it before you do anything. Oh, hold on. Just get those out of there. So let me look at your table. I'm going to leave R2 and PC3 and PC4 for you to do. Now notice the router doesn't need a default gateway because it is the default gateway. So then what you're going to do is go to VPC 1, and I say type IP and then x.x.x.x. What is that? X is the IP address of PC1. So if I come into PC1, I would type IP 192.168.0.2. Y is the subnet mask 255.255.255.252. And then Z is the default gateway. So PC1 will have 192.168.0.1 and hit enter. Then I'm going to go to PC2 and type 192.168.3.25. And I have a typo here. That should be 254. And the subnet mask is still 255.255.252.0. The default gateway would be 192.168.0.1. And then once we figure out R2, which I'll help you with that one. This one is, oops, .16.0.1 because it's the first one. Then we know PC2 has to be the next IP. And the subnet mask here for /26 will be 25192, right? Same subnet mask as R2. So I can put these in here. Okay, and then the default gateway for both PC 3 and PC 4 is R2's LAN. Okay, so all I want you to do, I'm not going to do this part for you, is you're going to have to figure out this. The network ID for this is 192.168.0.1. You need to figure out what the broadcast ID is, and then what the first, the second, and the third usable are. Now, I already gave you the first is 1, the second is 2, so you need to find the last usable IP address. And then once you get those, you're going to type those into all the PCs. Then you're going to go to R1 and enable and configure the 00 interface with its IP address, which in R1's IP address would be 192.168.0.1. The subnet mask is 255.255.252.0. And then type no shutdown exit, and then go to interface 10, put in its IP address and its subnet mask, and then go to no shutdown, Control Z to save it, and then write to memory. That will save the configuration in memory. And then do the same thing for R2. So for R2, you'll come in and you'll go to interface 00 IP address 172.16.0.1, 255.255.255.192, enter, no shut, enter, interface F A, and let me go to GNS3. Where do I have my GNS3? There it is. So if I come in here and show interfaces, so 00 and 01, 0's on the LAN, 10's on the WAN. So then I'll come into the WAN and I will configure its IP address for R2 and so forth. All right, and then I ask you, will you be able to ping from PC1 to R1's interface? You should. Tend to ping from PC1 to R1's WAN interface? You should. attempt to ping from R1's console terminal to PC1. So from R1, can you ping to PC1? That should be successful. And then from PC4 to R2's LAN, that should be successful. But can you ping to 1 to 4? And you'll find out what the answer is there, but then you'll have to go in and configure the routing protocol. All right. And then once we get the routing protocol and you have full network connectivity, which you should at the end have full network connectivity, I want you to go in and set up DHCP. So we're going to have DHCP on this router for this network, right? So here with our DHCP, so this side will be DHCP, right, which will be this network. And then this side will be DHCP for this network. Okay, so that's the kind of the last step is configure those. So once you get the DHCP going, and I give you the steps here for DHCP. So we're going to create a pool called left side, and then the network will be the network ID for R1's LAN, which is 192.168.0.0, and the subnet mask is 255.255.252.0, and then the default router will be the IP address for R1's LAN, so that'll be 192.168.0.1, and then domain names left.lab, the lease time will be 4 hours, and then we're going to create an exclusion for all the IP addresses except the first and the last usable. So you'll have to figure out what is the third usable IP address and what is the second to the last. And then we'll exclude everything so that we'll only be handing out the second and the last IP address. Then we'll do the same thing for the right side. And when you're done, you should be able to get the same IP addresses that you had before. So if you go to PC1 and type IP DHCP, it will reach out and touch the DHCP server, which is R1 on the left side. And then on PC3 and 4, it's the same thing, but it will go to the right side. Okay, then I ask you a couple of questions. When you're done, just upload this. Now, I want you to show me in the lab that you can communicate between all of the PCs once you have the routing protocol set up. And then also once you have your DHCP. All right, so show me that. Now, this lab, there's a section on the lab final, which will be in 2 weeks, right? In week 16, they'll be very similar to this lab. The only thing it won't really have is the DHCP, but the routing and all that will be part of that. All right, so that should be enough to get you going on this week's lab. Let me know if you have any questions. Again, we'll be in lab from 6:30 until 9:40. All right, talk to you later.